All right, so a little introduction to section 3.3 here, which is properties of logs, and just demonstrating these properties with some logarithms that we can actually evaluate and solve to maybe get an idea of how this works. So that's what I'll do with number 1 here. I'm just going to evaluate both of these. We know log 2 of 8 is 3, because 2 to the third power is 8, and log 2 of 4 is 2, since 2 squared is 4. Right, so we could just have these two, add them together, and work out to get 5. But to get some of the log properties that we can use in any situations, I'm actually going to rewrite this so we've got base 2 inside the logs. So you guys can see here, instead of writing it log 2 of 8, log 2 of 4, I've got log 2 of 2 to the third and log 2 of 2 squared. Now, just think about what we're doing with logarithms, right? Up here, since logs are exponents and we're adding those logs together, you can think about any other situations where we might add exponents. So where I have these two logs, now this part that we're adding together, we can actually rewrite this as one logarithm, log base 2, and I'm going to multiply these two bases together. Throw my equal sign in there. So now I've got log base 2 of 2 squared times 2 to the third, and remember what this is going to do since we add the exponents here. Log base 2 of 2 to the 2 plus 3, that's exactly what we did back at the top when we added 2 and 3. So we still get that same answer, 5. I do realize that I mixed up my exponents up here, right, in this first step, but that's okay since multiplication is commutative. So this demonstrates our product property. I'm going to fast forward this a little bit and write it out, where when we have two logs with the same base that are being added together, we can actually multiply what's in the logarithm. All right, now maybe we can kind of think about that same idea over here. If I just evaluate these logs first, we get log base 3 of 27 is 3, because 3 cubed is 27. And log base 3 of 1/9 is negative 2. Since 3 to the negative second is 1/9, we could add those together. So I want you guys to think about, well, when I'm really subtracting here, right? Let me rewind, right? We're not really adding together here, we're subtracting a negative. So think about what operation we could do in order to subtract exponents. So I'm going to rewrite this with the bases, log base 3 of 3, and log base 3 of 3 to the negative second power. And instead of writing these as two logs, where I'm just subtracting these answers, we can write it as one logarithm, where I divide the bases, because this will really allow us to subtract our exponents. And I'll get the same result as I had up top. And then we know log base 3 of 3 to the fifth is 5, right, based on our log properties. So this is our quotient property, or quotient rule, really quotient property we say for logs, where if we're subtracting two logs with the same bases, we can actually divide the arguments, right, because we would subtract those exponents. And really always remember, logs are exponents. So I'm just going to put out these two different situations for this last one. Right, again, writing 1 over 16 as my base 4, so 4 to the negative second. And then using our exponent properties, we know this is the same as log base 4 of 4 to the negative 6, where we're multiplying the exponents. And then 4 to what power is 4 to the negative 6? We would get negative 6 there. Well, another way we could rewrite this is move that 3 out front, right? Because this logarithm right here is really asking what exponent for 4 is 4 to the negative second, and then multiplying that exponent by 3. So I could evaluate that log and then just multiply it by 3 and get the same answer. So that's our last property, and that's called the power property. And it's when we have an exponent inside a logarithm, we can move it out front and multiply instead. So just hopefully a nice kind of example with regular values about why these power quotient and product properties work, and we'll move on to see these done with variables.